Hi everybody. Today we're going to be covering section 8.2, solving linear systems in 3 variables. Now this whole first page is a warm-up, so I want you guys to take a few minutes and work through these 2 problems. The first one you're going to solve using substitution, and then you're going to find the final answer. And then you're going to solve using linear combinations. Okay, so you're doing 2 methods for each problem. You should obviously get the same answer for both. So pause the video here and go ahead and complete both of these problems. Go ahead and check your solutions for number 1. You should have gotten an intersection point of 4, 4. Moving on to number 2, our intersection point was 2, -2. Now, depending on how the initial equation is set up, it might be easier for you to use elimination, it might be easier for you to use substitution. It doesn't really matter which method you use as long as you get to the right answer. So at this point, we're going to jump to the next page. And today we're going to talk about solving systems in 3 variables. Now you'll notice that this system here has an x, a y, and a z. Notice the variables should be on the left-hand side. Your constants are on the right-hand side. Okay, I will tend to give you problems that are already set up this way. Okay, now we have individual steps of how we're going to solve this problem. And actually this entire page is just meant to solve this one problem. And it is kind of broken down into individual steps, okay? So the first step says to isolate a variable with a coefficient of 1 from any of the given equations. Hint, your equation should look like x equals, y equals, or z equals. That's what it means to isolate a variable. You're getting it by itself. Now, we only need to do that for one of these equations, okay? So I'm going to look at this equation, and I can see in this top equation, I could pretty easily get the x by itself just by adding 2y and adding 3z to the other side. Okay, so if I were to, let's write that over here. This is the initial equation. If I add 2y and I add 3z, we just got x by itself. Okay, so I have x equals 2y plus 3z minus 1, okay? Now our next step says to substitute the expression found in step 1 into both of the other 2 equations. So we had used the first equation in this problem. So what we're going to be doing is substituting this x quantity. Notice I've got all this stuff, and we're going to replace x with this quantity. Again, it's just substitution. So if I were to write the second equation, I have 2 parentheses. This entire quantity gets substituted in. Okay, and then I have plus y plus z equals 6. And I'm going to do the same thing in the second equation. So I'm going to substitute that whole quantity in place of x. Then I have plus 3y minus 2z equals 13. And at this point, I just want to simplify both of these equations. So we'll have to do some distributing. combine some like terms. So I have 5y, 6z plus another z, that's 7z. And I'm actually going to move the 2 over to the right-hand side. We're getting this into standard form. Okay, so combine the y's, combine the z's, and then move that 2 over. We're going to do the same thing here. So combine the y's, we get 5y. Combine the z's, plus z. Move the 1 over, we get 14. Okay, so now you'll notice that we have 2 equations that have the same variables, and that's actually what it says here. If the previous step was done correctly, you should have 2 new equations with the same 2 variables in them. Now we can use elimination or substitution, just like how we did in the previous section. So if I have these 2 equations, this is now my system. So it's our choice of using elimination or substitution. I'm going to use elimination, and in order for me to do that, we have to have the same number in front of one of the variables, which I already do, but one's positive, I want the other one to be negative. So we're going to multiply every single number by -1. Okay, so what that does is it changes all of the signs to be the opposite. So that eliminates the 5y's because they cancel out, leaving us with 6z equals -6, because that 8 minus 14. Divide by 6, z is equal to -1. Now, as we know from the previous lesson, in order to find the other variable, we can just plug this -1 into one of the equations to find y. So I've got 5y plus -1 equals 14. I plugged it into this equation up here. Move the 1 over. And now we get y equals 3. So far, I've got 2 of my variables. I've got z, I've got y. Now I just need to find x. Now it says to use the values in step 3, and the answer from step 1, notice I have this expression up top, or this equation, that represents the x value. So I know that the x value, I'm just going to rewrite this whole equation down here, 2y plus 3z minus 1. Now, if I know z is -1, y is -3, I could just plug them in. And now we would just simplify. So I have 6 minus 3 minus 1. That gives me an x value of 2. Now our final solution can be written as what we call an ordered triple. It should always go in the order x, y, z. So we're going to start with x, then y, and then z. And that would be our final answer. Now number 6 says to check the solution in all 3 equations to see if it works. I'm not going to require that you guys do this. If you wanted to, you can take these 3 values, plug them in each of the equations, and they should all work. Okay, but at this point, I'm okay with leaving this as the final answer. Okay. Now we do have one more example of solving a system in 3 variables. If you feel confident in this process, or you want to just give it a try on your own, I'll pause the video here and you guys can give it a try. But because this is a newer concept, after the pause, I will also work through the whole problem together. Okay, so if you do want to try it on your own, go ahead and press pause. Okay, so we're going to be working through example number 2. Now, our first step is to isolate one of the variables. I could get this x by itself here just because it doesn't have a coefficient. I could probably get the y by itself, or even this x up top. Okay, so it doesn't really matter which one we decide to use. Let's use this x up top just because, since it's the first equation. So I have x plus 3y plus 2z equals 9. And I'm going to move the other two variables to the other side of the equation. So I have x equals 9 minus 3y minus 2z. Doesn't really matter the order that you put those letters in. Okay. Now our next step is to substitute this quantity. Remember, we're substituting into the other two equations. So I already dealt with the first equation. I'm going to substitute in place of x in both of those next equations. So I'm going to put this quantity in. So we've got 9 minus 3y minus 2z minus y plus 3z is equal to 16. That is the second equation. Now we're going to jump down to the bottom equation. I have 3 times this whole x value. Remember, it's just about substitution. Minus 4y plus 2z equals 28. And so now we just want to simplify both of these equations by combining like terms. I'm going to move the 9 over to the other side. Combine the y's, combine the x's, and combine those values. Do a little distributing here. And now I'm going to move the 27 over. Combine our like terms. So we've got negative 13 y. Combine our z's. We have just one on this side. So once we get this into standard form, so we call this standard form when the variables are on one side, constants on the other, we can create a system. So I've got negative 4y. I just like to rewrite it. You don't have to do this part, but I like having both equations right in front of me. And we can either use elimination or substitution. Okay, I tend to like elimination. Notice this is a negative 4z. If I multiply this top equation by 4, I'll have negative 16y plus 4z equals 28. And I'm going to rewrite the bottom equation. And you're going to notice that the z's are going to eliminate. They're going to cancel out, leaving us with negative 29y equals 29. Those numbers worked out kind of nicely. And now we see that y has to be negative 1. Just by dividing don't really have to show this step, but you get y equals -1. Now for us to find z, again, we're going to substitute back into one of the equations. I'll actually substitute into the top equation. Let's do -4 times the y value plus z equals 7. Okay, we end up with z is equal to 3. And now one of our last steps is to plug both of these values back into the first equation that we set up. So we had x equals 9 minus 3y minus 2z, and we're going to plug these values in. So we have 9 plus 3 minus 6, which should give us 6. And at this point, we have all three variables, x, y, and z, and we can write our final answer as 6, -1, and 3. And again, skip the check. That should be fine. All right, so that concludes our lesson on solving linear systems in 3 variables. The next page is your homework. We only have 2 problems here. Again, if you want to print this out, that's great. Otherwise, you can just write the problems in a notebook and take a picture to send in. Homework is due by the end of the day on Thursday. We will be having a quiz this Friday covering just the stuff we've done so far. So the systems in 3 variables and also basic elimination and substitution and graphing. All right, if you guys have any questions, you can contact me during office hours, either Wednesday or Thursday from 11 to 12. Thanks, have a great day.